Alright, I just wanted to double check a few things before I go, so I can write down some metrics to compare, because the new ones finally, or actually they came in a week ago. I just haven't had time to get around to them because I've been busy with other jobs. But I wanted to check something first. So, still pulsing low voltage. I wanted to see what the output does loaded and unloaded. Alright, that's good. And the ground is pin 3. Of course, the output is pin 6 and 7 over here. You can audibly hear it change when so we got 158 volts and 158. Let's see if my pin is still available. Write that down, and then I'm gonna, and the supply voltage should be the same as well, and that's going to be pins 2 and 3. .25. I wrote that down before, it's 8. And then I want to check 1 and 3 without hitting anything else, of course. 9.56. And I want to see what the feedback is doing as well. I was just looking to see if I was going to pick anything up on the timing circuit. 150 millivolts. And the IS is current sampling, resistance for the external current. Let me look and see if this has what it's using for current sampling. I wasn't really picking anything up. Sometimes these have a, there we go. Let me shut this off. Orient this in the correct. So these are your outputs over here, and current sampling. I don't know if y'all can see. This is your optocoupler for your feedback, and your feedback comes in here on pin 5, and then current sense showing to be R3, R4. See if I can see it. Not seeing anything for current sampling on this side. It might be R3 right here. R3, R4. Now if you're lucky, that you know, do I have a... This is for the one that's going on, which is kind of difficult to find. Let's see if they give me what the value might be. Of course, the application circuit they're giving is for 12 volt output. But if I remember right, when I checked the color bands on that, R3 was correct. Actually, I can just see if it is connected directly or not. Nope. Maybe this resistor here. Yep, that one is 1.4 ohms. If I remember right, it is a 1 ohm resistor on that. I just gotta find the, I think it's page 13 or something. Of course, I got these all out of order. Yeah, I'm sure all y'all saw that. I had it right under there until I knocked it loose, and then I saw it. So we're looking for, what are they giving for the value of R3 or R4? You know, 2.2 or 1.5, and that's what we're reading. Alright, so now I want to get myself back in order. And write down what my loaded and unloaded, if I spell loaded correctly. Without the load on it. And see what I'm looking at. So 166, 166, 150. $50 millivolt. And then is my VCC the same or higher? I can still hear this thing chirping away. A little bit lower. At 8. See if I can get in there to move that out of the way. We got 8.8 on OB terminal. Alright, so let's shut this off. So basically, what I'm showing is, you know, there's a, in the output voltage loaded versus unloaded, it's dropping 8 volts. And it seems, you know, 8 volts through the switching transformer, it's dropping the output basically 8 volts. Which is, you know, what we're seeing. So let's get to changing out this PWM. Get this out of the way and try not to lose my screws. Looks like there's just 2 screws holding this on here. And these seem to be the shortest ones of the bunch. Plug this thing. Really nothing going on the bottom. Yeah. Looks like it's the same size. Hopefully these are good. I've had some of them. If y'all see my previous videos with those IPM chips, I had a handful of them that were DOA. So I'm just going to start by clipping the tops off of them. Yeah, everything I think I'm going to need. Man, some of my fluxes. No bueno. Go ahead and refill my alcohol since it's getting low. Alright, now let me see if I can get this zoomed in enough for you guys to see. Of course, it gets real pixelated because I'm just relying on digital zoom. But I'm just going to get in here and move some of this out of the way as best I can and carefully, I say carefully, but I can get in there and cut the legs off of it. Because these cheap breadboards, you don't want to heat cycle them too many times because they tend to just burn right off. They're not a high class board, so they don't handle heat cycles too many times without burning a ring or a barrel, because of course these are just meant to be disposable. remember where I put my vise at. Hold this thing. Yeah, because sure I can disconnect these, but I can get a little bit of slack to get this oriented where I want it. It might hold it upright if I can coax enough room out of my little workbench here. Just get it low. I think I'm just gonna I'll be my way doing it like that. Yeah, it sucks when there's really not anything to grab onto. I'm gonna try and angle this. It ain't gonna be the best for y'all, but I gotta get to one side and pull with the other side. Of course, I had it all zoomed in and y'all really can't see nothing doing it like that. That's probably about as good as it's going to get. And of course, I should have turned the soldering iron on. The thought passed through my head, but never followed through with it. Love you too.
That was me knocking the door.
Yes, I heard.
How do you get?
Mm-hmm.
Yeah. I'm just a big girl.
You're a big girl now? Okay.
Dad,
Hmm.
Daddy,
Love you too, Charlotte.
when Mama gets home,
Mm-hmm.
should it come up for us with me and Papa?
I don't know.
Maybe she's going back to work.
I don't know. We'll find out. I'm just going to leave that in there. See if this is making enough heat yet. Of course, this is all lead-free solder in here, so it very, very challenging. Let me turn the fan on. Behind me. At least blow all this away from me. Of course, this is hard to see because there ain't a lot of room to work. But I'm going to start at the bottom and work up. One out. Of course, after you get all the pins out, you gotta wick the old stuff out. Now moving to the other side. Come on. is that not good? Man, that one does not want to come out. I'll have to try from the other side. Of course, now I really can't see what I'm doing. Yeah, that's why. It wasn't the wrong damn pin. All right. Let's see if the solder sucker's any good still. Get some of this out of there. Sometimes these work and sometimes there's too many components around them to effectively use them. Looks like it got something out of it. I'll clean the rest up with some wick and flux. Capacitor's in the way over here. I'll do my best. Yeah, the rest of that's gonna have to be whipped off of there.
I found a heart lollipop.
Oh, you did?
Okay, look.
Where'd you find it?
In a box.
In a box? Where?
So we're hiding.
Hiding? Are you sure they were hiding because you weren't supposed to have one? I think that means she's busted. When your 4-year-old comes and shows me that they found a lollipop that was hiding, and then you say, well, I guess that means it was hiding because you weren't supposed to have one, and then they just vicariously go back inside. Let's see if this flux wants to cooperate. Hey, it's coming off of there at least. That's good. Looks like it's out of there enough I can get the new shit back in there. Clean some of this out of my working space. I made a little bit of a mess. Let's see if I can get and push the toothbrush through some of these holes to get that stuff out of there. Man, I'm already an hour into this. I thought this was going to be a quick 20-minute change-o. Nope, never works that way, does it? Let go. Alright, let's try this again. I know that's nice and grainy for y'all, but that's what I got for right now. Yeah. I need to clean my sponge off again. It's not wanting to whip. There it goes. Make sure nothing's bridged. Nope. Those are bridged. It's grounded where it should be. Try this again. We're getting. .6. Just checking to make sure nothing's shorted out on my light ring here. Or it just could be that this one is not capable of the current that it needs to be, and that's why it's pulsing, which is incompatible. And the internet was wrong, because this one says the switching current peak value is 800 milliamps, which should be adequate. Of course, the recommended on here it shows you the 600 milliamp is the recommended switching current peak value. And this one's showing its max, its limit is 800, and if the ring is still meeting 750, it should work. Should is the key word. Alright, just an update here. For reasons I'm not certain, other than possibly there was some coupling going on. Whoa. Goes calling me a liar. Now it works fine. I was going through and checking to make sure everything was fine, and then I had the idea to hook my power supply up and got my hot lead on the diode there, and or sorry, my negative on the diode there for the ground plane, and then my positive here on D4 to provide the VCC stable at 8 volts for the PWM controller. And now it seems, after leaving it on for a while, it's stabilized. See, now it's stabilized. And even the output voltage is, 19 or 20 is what I was measuring a second ago. That's interesting. Now watch me put it back together and it doesn't want to work. As I got last video went a little long, so I decided to keep digging away at it and try a couple more things. And I'm not certain why it actually is working, other than there was some, other than the latching circuit, the on the OB terminal was actually, how do they describe it in here? Startup current and the startup resistance. Of course, I got them all out of order again, as usual. This is here, during the startup phase, VR is closed when the electrified FP pull-up power source is closed. The startup current is input from power to tube to VCC through OE. OB controls the base current of power tube and limits the current of power tube collector. Starts the acceptance currents according to the security of the power tube and is ensured when the VCC voltage goes up to 8.8. The startup phase is ended and comes to a normal phase. During normal phase, VCC shall keep between 4.8 to 9 volts. Output 2.5 volt benchmark to the pull-up resistor, and I was getting 1.8 when I was measuring a second ago. If the feedback is less than 1.8, between 1.2 and 1.8, the cycle the oscillator will increase with it, and the less the feedback is, the wider the cycle of the oscillator, yada yada yada. Alright, so let me just double check the feedback. .8. Sorry if y'all can't see that. 1.87. Alright, so let's turn this off and see if it'll go back together and still work. That'll be the magic. I think I may have scattered some of my screws. Put those. There they are. Yeah, because for some reason the collector current voltage, supply voltage, stabilized after I gave it a stable source for some period of time, and I'm not certain why. Yeah, because none of this was loose. Get all this back in here. Alright, so what did I do that now it's pulsing again? Alright. I had a feeling that was going to happen. Yeah, let me. Hook it back up and see what's going on with it. There we go. I'm sure it's glaring it quite nicely. Does it stay on? See? Turn the power supply off and it stays on. Alright, so we may have a grounding issue. Because as soon as I remove the ground, it I have an unstable ground somewhere. Or broken ground. Yep. So with this all being analog ground, it makes things let's see if I remove power if it still does it. Point two. $48, $49, $49. And my original measurements were 158 and 166 unloaded. Of course, I need to unplug that. Of course, it's dim now. 60. Yeah. And my output has dropped to 15. Definitely have an issue with the yeah, it's like it's not coupling. Alright, I think I might take a break and eat lunch and then revisit this. Alright, here's an update. It works now, and it's stable. After quite a lot of tinkering, some odd hours have passed by. I started change the values of the current resistor for OB, which controls the gate. See if I can bungle through these again and find it. Let me just shut this off. Alright, so what I did was there is you can see there's a 2.2 meg resistor from the main power rail, which is about 165 volts, that goes into the OB terminal. OB terminal is right here, and you can see it ties in to the slope current drive and the startup current, and it operates the gate for Q1 right here. And then you have your collector and your emitter on this in channel. And I decided I played around with the various resistors and didn't make any difference. So then I started playing around with capacitance because I noticed this one's calling for 47 microfarad, and the one that was on there is a 22. You can see it. A little 22. Come on, focus. 22. So I ran another 20 in parallel to it, and it came on. But since I didn't want to have a large 20 like this one hanging off the bottom, I stuck a 100 on it, and now it kind of works just like factory, where there's a small delay and it stabilizes the collector voltage. And it works now. Let me just reduce the blindness and I'll show you that everything's stabilized. See if I can get the meter in frame. Reversed. Come on. Reorient this thing. $19.2. And output's 128. And then we got 147. So it's not maximum output, but it's bright enough to work now. So go ahead and turn this off, put it all back together, and we'll have a working magnifier again. There we go.